This course is not a substitute for on-the-job training or other requirements of your state or local agency. Always follow federal, state, and local regulations. This course does not replace any required training by the manufacturer of their fumigant gas products. This course is for continuing education requirements only. This course is provided with permission of Douglas Products. This course is not a Douglas Products or Vikane-sponsored course. Please read and follow label directions. American Pest CEUs thanks Douglas Products for allowing the use of this publication. Vikane Structural Fumigation Manual for use exclusively with Vikane gas fumigant. These materials have been created specifically for Vikane gas fumigant and no other structural fumigant. The information contained in these materials is product labeling and use instructions for Vikane and is not intended for use with other structural fumigants, which will have different product label requirements. These materials may not be copied in whole or in part or reproduced without the permission of Douglas Products. Part 6, Release of the Warning Agent, page 5 through 21. Part 7, Vikane Introduction, page 22 through 39. Part 8, Monitoring Vikane, page 40 through 44. Part 9, Aerating and Clearance Testing, page 45 through 67. Part 10, Site-Specific Considerations, page 68 through 86, such as chambers, vehicles, ships, passenger rail cars. How to measure a building to be fumigated with Vikane gas fumigant, page 87 through 101. Release of warning agent, 6. Vikane has no intrinsic warning properties such as odor. The warning agent chloropicrin is released before introducing Vikane to allow time for it to begin to volatilize and distribute throughout the space to be fumigated. The warning agent chloropicrin must be released into the fumigated space at least 5 to 10 minutes before introduction of Vikane. The only exception to use of chloropicrin would be when fumigating passenger rail cars in permanent and temporary fumigation chambers, including but not limited to shipping containers, storage pods, trailers, and trucks with the following requirements. A thorough walkthrough inspection must be performed of each rail car chamber with doors being locked immediately upon leaving. For rail cars, a guard must be posted during fumigant introduction, exposure period, and aeration if chloropicrin is not used. A guard is not required for permanent and temporary fumigation chambers unless required by state regulations. If locking devices or barricades are installed that are demonstratively effective in preventing the fumigated space from being entered using normal opening or entering processes by anyone other than the certified applicator in charge of the fumigation or persons in his or her on-site direct supervision. Safety precautions when using chloropicrin. Chloropicrin is a warning agent that causes smarting of the eyes, tears, discomfort, and has a very disagreeable pungent odor at very low concentrations. Chloropicrin must be used by a person certified to apply Vikane or under their supervision. Applicators must observe the chloropicrin precautionary statements and personal protective equipment appearing on this label. Chloropicrin must be applied by persons certified to apply Vikane or under their supervision on site, with a second person trained in use of the chloropicrin being available on site. Personal protective equipment. Some materials that are chemical resistant to this product are nitrile and butyl. For more options, follow the instructions for Category F on the Chemical Resistance Category Selection Chart. All persons applying chloropicrin must wear long-sleeve shirt and long pants, chemical-resistant gloves, protective eyewear, or a face shield. Do not wear goggles. Persons applying chloropicrin must wear either a positive pressure self-contained breathing apparatus or combination air-supplied SCBA when applying chloropicrin to more than 2 chloropicrin introduction points within a single fumigated structure. The employer of any person applying chloropicrin must make sure that they are provided and correctly wear the required personal protective equipment. Follow manufacturer's instructions for cleaning, maintaining PPE. If no such instructions for washables exist, use detergent and hot water. Keep and wash PPE separately from other laundry. First aid. First aid recommendations such as time to flush eyes or skin if contacted by chloropicrin vary depending upon the product label. General first aid procedures are as follows. If inhaled, move person to fresh air. Keep warm. If person is not breathing, call 911 or an ambulance. Then give artificial respiration, preferably by mouth to mouth if possible. Do not give anything by mouth to an unconscious person. Call a poison control center or doctor for further treatment advice. If on skin or clothing, immediately remove contaminated clothing, shoes, or any other item on skin. Rinse skin immediately with plenty of water for 15 to 20 minutes. Call a poison control center or doctor for treatment advice. First aid. If in eyes, hold eye open and rinse slowly and gently with water for 15 to 20 minutes. Remove contact lenses if present after the first 5 minutes, then continue rinsing eye. Call a poison control center or doctor for treatment advice. If swallow, call a poison control center or doctor for treatment advice. Have persons sip a glass of water if able to swallow. Do not induce vomiting unless told to do so by a poison control center or doctor. Do not give anything by mouth to an unconscious person. Note to physician, chloropicrin is a volatile liquid that is an active ingredient in tear gas. As a gas, it is a powerful lacrimator. Symptoms of overexposure are profuse lacrimation, respiratory distress, and vomiting. Pulmonary edema may develop later. Storage and handling. Storage. Store upright in a cool, dry, well-ventilated area under lock and key. Store only in original container. Do not contaminate water, food, or feed by storage or disposal. Spill and leak procedures. Evacuate immediate area of spill or leak. Use a self-contained breathing apparatus, SCBA, for entry into affected area to correct the problem. Move the leaking or damaged containers outdoors or to an isolated location, observing strict safety precautions. Work upwind if possible. Allow spilled material to evaporate or absorb onto vermiculite, dry sand, earth, or similar absorbent material. Thoroughly aerate absorbent materials outdoors prior to disposing on site or at an approved disposal facility. Do not permit entry into spill area or cleanup area by unprotected persons until chloropicrin is aerated. Disposal. If the chloropicrin container is disposable and is non-returnable to the supplier, it is recommended to aerate the empty container opened, for instance, cap off, within the fumigated space during fumigation. The location should be close to a fan and or chloropicrin introduction site. Replace cap after it has been aerated inside of the fumigated space. Close the container, for instance, replace the cap, and dispose in a sanitary landfill or by other approved state and local procedures. Introduction of chloropicrin. Research indicates that when chloropicrin is applied according to label directions at each introduction site for Vikane, it will rapidly reach and maintain warning concentrations throughout the fumigated space for the fumigation exposure period. In order for chloropicrin to perform effectively as a warning agent, it must be applied in a shallow container with fresh wicking material in the airstream of a fan, at a rate of 1 ounce per 10,000 to 15,000 cubic feet, or follow dosage rate calculated by the electronic Fumigide system. Since November 2007, new and upgraded electronic Fumigides now calculate a maximum and minimal chloropicrin dose in ounces to apply. The maximum ounce dose will be based upon 1 ounce per 10,000 cubic feet. The minimum ounce dose will be based on the structure size, under seal, slab, or soil, and fumigant exposure time, at not more than 3 fluid ounces of chloropicrin per evaporation container, at 1 or more chloropicrin introduction sites for each 45,000 cubic feet of space to be fumigated. In addition, it is suggested that chloropicrin be introduced on each floor of a multi-story structure at each introduction site of Vikane, in areas without excessive furnishings and contents to absorb chloropicrin. When applying chloropicrin at multiple chloropicrin introduction points within a structure, start at the point farthest from the exit and work towards the exit. Additional precautions for use and handling of chloropicrin. Do not rely upon chloropicrin as the only deterrent to unauthorized entry during the fumigation. Follow all label, state, and local regulations for conducting the final inspection to ensure the fumigation site is vacated of people, pets, and domestic animals prior to fumigant introduction, securing structure entrances, and posting of warning signs. State and local regulations may require additional security measures, such as posting of guards. Use a measuring device to measure the calculated volume of chloropicrin to apply. Measuring devices with a graduated scale for fluid ounces and reclosable caps are available. An additional advantage of using these devices is that chloropicrin can be measured outside the structure, so only the amount of chloropicrin needed during the fumigation is carried into the structure. Additional precautions for use and handling of chloropicrin. Do not apply liquid chloropicrin directly to soil, concrete, or wood in the fumigated space. Odor from chloropicrin desorbing from these surfaces after direct application can be persistent and difficult to remove. Do not apply chloropicrin in containers made of magnesium, aluminum, or their alloys, since chloropicrin is corrosive to these metals. Removal of all chloropicrin evaporation containers from the fumigated space during initial phase of aeration after tarp removal may aid in the dissipation of the warning agent from the structure. Additional precautions for use and handling of chloropicrin. The DOT regulates the transportation of chloropicrin. Regulations include transporting chloropicrin in a DOT-approved shipping container secured in a separate airspace from the driver and the vehicle occupants, in a placarded vehicle operated by a driver with a commercial driver's license with hazmat endorsement. Contact your local distributor or Douglas Products for information on purchasing evaporation containers, measuring devices for chloropicrin, liquid or airborne concentrations, and training sources for DOT regulations. Vikane introduction 7. Preventing property damage. Improper introduction of Vikane may cause property damage from the following processes. Liquid Vikane directly contacting surfaces and causing freeze damage or corrosion. Gaseous Vikane is non-corrosive. Vikane introduction 7. Preventing property damage continued. Excessive condensation called a fog-out causing staining, tarnishing, or corrosion. As described in the chapter on fumigation preparation, when liquid Vikane is released from the introduction hole, it extracts heat from the surrounding air as it expands to form a gas. The chilling can cause the formation of a cloud of condensed water, fog, that should be dissipated before it collects on surfaces. Minute quantities of certain byproducts in Vikane may cause susceptible surfaces such as metals, tile, glass, and carpeting during a fog out when they are dissolved in water at sufficient concentrations at the introduction location. These byproducts are of no consequence in the gaseous phase. Release of Vikane as a liquid, not a gas, and fog outs can be prevented by the applicator selecting the appropriate fumigant introduction release locations, introduction hoses, and fans as described below. Choosing fumigant introduction locations. Apply Vikane in a manner to achieve equilibrium, minimize fog out potential or damage to fumigated materials, and ensure safety to personnel, pets, and domestic animals. Considerations for introduction location selections include 1. The largest open space where fumigant will not be applied directly to any surface. Choosing fumigant introduction locations continued. 2. Areas without excessive contents. For instance, clutter, mini boxes, overstuffed furniture, and pillows, to absorb chloropicrin, since it is suggested that chloropicrin be applied at each introduction site for Vikane. 3. Multiple introduction sites may be necessary if the structure is large, multi-story, has multiple firewalls, or is compartmentalized, or if high dose rates of Vikane are applied. A. One fumigant introduction site for each 20 to 45,000 cubic feet in residential dwellings or similar compartmentalized structures is recommended. B. At least one introduction site on each floor of a multi-story structure is recommended. Unfinished attics and crawl spaces generally are not used as introduction sites to introduce Vikane due to the potential for fog outs. Selection and use of equipment for fumigant introduction. Select equipment for the introduction of Vikane to meet the following criteria. Reliably measure the amount of Vikane being introduced. Not damage the cylinder of Vikane or valve. Not break down or contaminate Vikane. Confine Vikane until it is released into fumigation area. Prevent a fog out and liquid sulfuryl fluoride from contacting surfaces that could be damaged. Enhance fumigant distribution to reach equilibrium. Weighing the fumigant. Measure the pounds of Vikane introduced using equipment such as weighing scales. Platform or hanging scales can be used to weigh the cylinder containing Vikane during fumigant introduction to determine the pounds of fumigant introduced. If hanging scales are used, hanging bonnets or similar devices designed for this purpose must be used to hang the cylinder from the scale. Consult Douglas Products or your distributor of Vikane for sources of hanging bonnets or cylinder slings. Never suspend the cylinder containing Vikane by the valve. Hoses. Release Vikane through an introduction hose that meets the following criteria. Leak-proof hose with a minimum burst pressure of 500 pounds per square inch, PSI. Should be flexible, kink-resistant, durable, and compatible with liquid Vikane. Has appropriate diameter and length to control the introduction rate of Vikane so fan capacity is not exceeded. Vikane is introduced into the blast of air from one or more fans having a total capacity of at least 1,000 cubic feet per minute, CFM, for each pound of Vikane released per minute. Tables 7A and 7B below can be used to select the appropriate diameter and length of introduction hose to obtain the desired introduction rate for Vikane based on fan capacity. The maximum introduction rate for Vikane is also calculated by the Fumigation electronic calculator based on fan amps and relative humidity. Table 7A, effect of inside diameter size on introduction rate of Vikane through a 25-foot polyethylene hose at 65 degrees Fahrenheit. Tube inside diameter ID 1/8 would be pounds Vikane per minute would be 4. Tube inside diameter ID 1/4 pounds Vikane per minute would be 20. Tube inside diameter ID 1/2 pounds Vikane per minute would be 45. Table 7B, effect of hose length 1/8 inch ID on introduction rate of Vikane at 65 degrees Fahrenheit. Hose length feet 25 pounds Vikane per minute would be 4.0. Hose length feet 50 pounds Vikane per minute would be 2.8. Hose length 100 feet pounds Vikane per minute would be 2.01. 1. Where fumigant introduction rates lower than 2 pounds per minute are needed, a longer hose can be used, for instance a 200 foot. Use of 1/8 inch ID introduction hose of about 100 feet in length will provide a fumigant introduction rate for dry wood termite fumigations that will not exceed the capacity of most standard industry fans. Prior to use, confirm with distributor or manufacturer that the introduction hose meets the above requirements. Secure an introduction hose. Secure the introduction hose to the introduction fan, an introduction stand, or by other means to avoid damaging surfaces, furnishings, or structural features. A commonly used method is to securely attach the introduction hose to a Torque clamp and then use the Torque clamp to attach the hose to the fan cage. The fan cage is then angled upward at about 45 degrees. Introduction hoses should not be attached to customer furnishings or structural features such as doorknobs to avoid damaging surfaces of these items by clamping, taping, or contact with liquid Vikane. It is recommended to leave the introduction hose in place during the fumigation exposure period in case additional fumigants need to be introduced later depending upon the fumigant confinement condition. Fan placement and specifications. Refer to the chapter on fumigation preparation for complete directions and recommendations on fan specifications and placement prior to introduction. Protective sheeting. It is recommended that protective sheeting such as polyethylene, plastic, or tarps be placed under the introduction stand if used. Hose and fan to further protect floors and floor coverings during application. All of the fumigant introduction options outlined above offer the flexibility to incorporate protective sheeting in critical areas. Chloropicrin introduction. Chloropicrin can be introduced at introduction sites for Vikane. Chloropicrin must be used within the structure at least 5 to 10 minutes prior to the introduction of Vikane. Complete directions and recommendations for chloropicrin use and handling are reviewed in the chapter Release of Warning Agent. Safety equipment. Wear splash-resistant goggles. Goggles designed and made of materials that allows no measurable movement of the liquid pesticide being used to pass through them during use, or a full face shield for eye protection during introduction of the fumigant. Do not wear gloves or rubber boots. Do not reuse clothing or shoes that have become contaminated with liquid Vikane until thoroughly aerated and cleaned. Have proper respirator protection, SCBA, available in case of an emergency, such as a ruptured introduction hose. Follow label, state, and local regulations regarding inspection of the space to be fumigated prior to the release of the fumigant. Releasing Vikane from the cylinder. Refer to the chapter Cylinder Handling and Storage for a complete description of cylinder configuration and handling. Each cylinder of Vikane is equipped with a dip tube that extends from the bottom of the tank to a valve on the top. To release the fumigant, this valve is open to permit a free flow of the liquid, which vaporizes as it escapes from the introduction hose. The valve should be turned fully open to fill the fumigant introduction hose with liquid Vikane. Initially, the valve should be opened slightly until flow has begun, and then opened about one full turn, which should give full flow through the fumigant introduction hose. When finished, close the valve tightly using an appropriate wrench with a handle of sufficient length to provide the necessary torque. A clearance detector or leak detector may be used to test for a tight seal of the introduction hose at the cylinder valve. Contact Douglas Products for information on the types of wrenches that should be used to open and close valves of cylinders of Vikane. Frozen Frozen cylinders. If there is a break in the dip tube in the cylinder, a rare occurrence, Vikane will be discharged through the valve and introduction hose as a gas, not a liquid, when the liquid level falls below the break in the broken dip tube. As the liquid expands in the cylinder, heat will be extracted from the surrounding area as described above, and the cylinder will frost or freeze at that point. Vikane will be discharged, but at a slower rate because it is in the gaseous phase. Cylinders showing signs of a broken dip tube should be returned to the distributor. See chapter on cylinder handling and storage so that the problem can be repaired before refilling. Contact your distributor of Vikane for instructions on documentation and return of a potentially malfunctioning cylinder. Releasing the last 3 to 5 pounds of Vikane. The final pounds of Vikane in a cylinder generally are in a gaseous state and will move through the introduction hose more slowly than will the liquid fumigant. Testing by Douglas Products has determined that it can take up to 20 minutes at 75 degrees Fahrenheit air temp to release the last 2 pounds of sulfuryl fluoride from a compressed gas cylinder. Monitoring Vikane. 8. The goal in monitoring fumigant concentration during the fumigation exposure time is to calculate the actual HLT and ounce-hour dosage accumulation. This allows the applicator to adjust the fumigation if needed by adding more fumigant or modifying the exposure time, so the necessary ounce-hour dosage is accumulated. Monitoring a fumigation is not required by the label for Vikane, but may be requested by a customer or by regulatory officials in certain conditions for verification of ounce-hour dosage accumulation. Guidelines for monitoring a fumigation. 1. Consider monitoring Vikane in the space most representative of the atmosphere in the structure, such as the living space of a residential building. In large jobs, multiple sampling locations may be appropriate. Monitoring can also be conducted in the attic and/or crawl space, if present and accessible, to determine fumigant distribution throughout the structure. 2. In partitioned structures, monitoring samples should be taken from the separate sections, such as each floor of a multi-story building. 3. The time required between the measurements to determine the actual HLT will depend upon the fumigant confinement. The time between readings should be sufficient to detect a change in the fumigant concentration. Usually 2 to 4 hours will be adequate, but in the case of structures with excellent confinement, more time may be required. 4. To confirm the total ounce-hour dosage accumulated, the fumigated space will need to be monitored at 2 time intervals occurring approximately at equilibrium and prior to aeration. Equipment. Fumigide calculator. The Fumigide electronic calculator can be used for both non-monitored and monitored fumigations. The Fumigide Y may also be used for monitored fumigations. These calculators require 2 fumigant concentration measurements taken at 2 different time intervals following fumigant introduction and the time between the 2 measurements to calculate an actual HLT and ounce-hour dosage accumulation. Monitoring hoses. Monitoring hoses for sampling fumigant concentrations should be placed in the structure prior to fumigant introduction. Semi-rigid hoses, typically 1/8 inch to 1/2 inch ID, are used. Monitoring hoses larger than 1/2 inch ID may take a longer time to pull the sample from the fumigated space to the monitoring device because of the larger volume of air needed to be moved. Monitoring equipment. The fumoscope using a thermal conductivity sensor is an example of equipment commonly used to measure concentrations of Vikane during the fumigation exposure time. The fumoscope, including models EV, E-200, D 5.0, and RDA, is not sensitive enough to use as a clearing device after aeration of Vikane. Follow all manufacturers' recommendations for use and collaboration of fumoscope. Contact distributors and Douglas Products for information on where to purchase or repair equipment such as the fumoscope for monitoring fumigations of Vikane. Aerating and clearance testing. 9. When used for fumigation of enclosed spaces, 2 persons trained in the use of this product, at least one being an applicator who is licensed, certified by the state, must be present during the initiation of the initial aeration procedure. Preparing for aeration. When preparing the fumigation, it is recommended to plan ahead for the aeration period and take steps to aid aeration by strategic placement of fans and other aeration tools. The fans used for fumigant introduction and distribution, Figure 9A, may need to be repositioned to enhance aeration, Figure 9B. The most efficient use of the aeration fans is to position so airflow is moving in one direction. This is done by positioning fans for fresh air intake in openings on one side of the structure and fans for exhausting fumigant in openings on the opposite side of the structure, Figure 9B. Consult local regulations for any additional requirements or restrictions for aeration procedures. Figure 9A, example of fan placement for introduction and distribution of Vikane. Figure 9B, example of fans repositioned for unidirectional flow for aeration of Vikane. Aeration procedures. Aeration procedures available to the fumigator may vary depending upon the state. Refer to the label registered in the state, your distributor, or your Douglas Products representative for further information. No one should be in treated areas if the level of Vikane is above 1 parts per million or if the level of Vikane is unknown, unless provided with a NIOSH or MSHA approved positive self-contained breathing apparatus, SCBA, not SCUBA, or combination air supplied SCBA respirators such as manufactured by Ranger, Survivor, Scott, or MSA. Aeration procedures 1 and 2 are as follows. All structures fumigated at 16 ounce per 1,000 cubic feet or less may be aerated using procedures 1 or 2. All structures fumigated at concentrations greater than 16 ounce per 1,000 cubic feet must be aerated using procedure 2. Aeration procedure 1. These steps must be completed in sequence. Step 1. Aerate structure with all operable windows and doors open, aided by the use of one or more fans, for a minimum of 1 hour. Total fan capacity using one or more fans shall be capable of displacing a total of 5,000 cubic feet per minute. Step 2. Secure structure and do not allow re-entry for a minimum of 6 hours from the start of aeration, first opening of the seal. During this time, structures must remain posted. Step 3. After the minimum 6-hour waiting period, measure the concentration of Vikane in breathing zones of each room. Breathing zones are defined as areas within the structure where individuals typically stand, sit, or lie down. If the concentration of Vikane is greater than 1 part per million, further aeration and retesting are required. If the concentration of Vikane is greater than 1 part per million, ventilate structure with operable doors and windows open and confirm concentrations are 1 part per million or less before the structure is reoccupied. Aeration procedure 2. These steps must be completed in sequence. Step 1. Aerate structure with all operable windows and doors open, aided by the use of one or more fans, for a minimum of 1 hour. Total fan capacity using one or more fans shall be capable of displacing a total of 5,000 cubic feet per minute. Step 2. Secure the structure and do not allow re-entry for a minimum of 8 hours from the start of aeration, first opening of the seal. During this time, the structure must remain posted. Aeration procedure 2. Step 3. After the minimum 8-hour waiting period, measure the concentrations of Vikane in breathing zones of each room. Breathing zones are defined as areas within the structure where individuals typically stand, sit, or lie down. If the concentration of Vikane is greater than 1 part per million, further aeration and retesting are required. If the concentration of Vikane is greater than 1 part per million, ventilate structure with operable doors and windows open and confirm concentrations are 1 part per million or less before the structure is reoccupied. Aeration procedure 2. Aeration procedures 1 and 2 require the applicator to aerate the structure with operable doors and windows open and with the aid of one or more fans for a minimum of 1 hour. This active ventilation is required to enhance fumigant diffusion and prevent fumigant concentrations from exceeding 1 part per million following clearance. These aeration procedures have been tested under a variety of structural and environmental conditions typically encountered while conducting structural fumigations. The applicator may increase the total aeration period beyond a total of 6 to 8 hours for ease in scheduling. During the initial 1-hour aeration procedure, approved respiratory protection must be worn until the concentration of Vikane is confirmed not to exceed 1 part per million with an improved detection device. Since the Interscan, Myron, Cephalory, and Spectrus Explorer gas analyzers give immediate readings, respiratory protection is not required when clearing with these instruments after having completed the initial 1-hour aeration procedure. If a reading indicates levels in excess of 1 parts per million, leave the affected area immediately. At the conclusion of the aeration period, the structure and any connected structure must be tested with an approved detection device of sufficient sensitivity, such as the Interscan, Myron, Cephalory, or Spectrus Explorer gas analyzers to confirm a concentration of Vikane of 1 parts per million or less in the breathing zone of each room. Breathing zones are defined as areas within the structure where individuals typically stand, sit, or lie down. If the concentration of Vikane is greater than 1 parts per million, further aeration and retesting is required. Clearance testing equipment. The Interscan Myron, Safari, or Spectros Explorer gas analyzers are approved detection devices of sufficient sensitivity to clear structures following fumigation with Vikane. All are continuous reading instruments which may be battery operated. The Interscan model of GF 1900 has an integral pump that draws the air sample through a pyrolyzer furnace where the sulfuryl fluoride is converted to SO2, which then passes through an SO2 sensor. The sensor output is registered on a direct reading dial as parts per million of sulfuryl fluoride. The unit can also be AC powered. The Myron sulfuryl utilizes a single beam infrared detection technology to directly measure low concentrations, 0 to 5 parts per million of sulfuryl fluoride. The Spectros Explorer utilizes a non-dispersive infrared NDIR technology to directly measure sulfuryl fluoride. The monitor contains an integral purge airbag, which is used to automatically re-zero readings. The purge airbag must be refilled with fresh air about every 30 minutes of detector operation. Prior to using these instruments to clear a structure for reoccupancy, follow the manufacturer's directions for filling the internal airbag for the Explorer and for zeroing the meters for the Interscan and Myron analyzers. Manufacturer's instructions also include information regarding appropriate and necessary calibration and maintenance. Documentation to verify the last calibration check of the clearance device being used is often requested by state regulatory enforcement personnel during inspections of fumigation operations. Manufacturers' recommendations must be followed to ensure proper operation of these instruments. Contact your distributor or Douglas Products for information on where to purchase and service these detectors. New devices may be developed to detect Vikane. Contact your nearest representative from Douglas Products for the latest information on detection devices. Reoccupancy. Until the final clearance is verified, the structure is still considered under fumigation and appropriate precautions are to be taken, such as warning signs remaining posted on all entrances. Do not allow reoccupancy of any fumigated area until the aeration and clearing process is complete according to the directions, and concentrations of Vikane do not exceed 1 parts per million as determined by the use of a detection device with sufficient sensitivity. Only a certified applicator may authorize the removal of the warning signs. Consult local authorities for instructions regarding documentations of clearance, such as posting clearance notices. Follow all federal, state, and local requirements for reoccupancy. Aerating chloropicrin. The following procedures are contained on the label for Vikane to aid in aerating chloropicrin. Open all operable attic doors and accesses and direct a fan into the attic. If the structure has an attached garage, the door between the garage and the structure should be open. If the structure has a central air handling system, the fan or blower should be activated for each unit if operational. As an alternative, a fan may be placed in front of a furnace inlet to blow air into central heating and cooling ducts. Aerating passenger rail cars. Passenger rail cars may be aerated using either of the following two aeration procedures. Rail cars must remain posted until cleared for reoccupancy. Aeration Procedure 1. If onboard railcar ventilation systems are not operable, aerate railcar for a minimum of 6 hours using the following procedure. Step 1. Remove all tape, seals, and/or tarps. Step 2. Open all exterior railcar doors. Step 3. Open all internal doors such as cabinets, closets, appliances, and sleeping berths. Aeration Procedure 1. Aerating passenger rail cars. Continued. Step 4. In sleeper cars, turn all mattresses askew to expose cavities beneath sleeping berths. Step 5. Ventilate the rail cars for a minimum of 1 hour with enough portable fans to provide a minimum 4,000 cubic feet per minute capacity per floor. A bi-level rail car would require 8,000 cubic feet per minute capacity or greater than 4,000 cubic feet per minute per floor. Direct fans in such a manner to create cross ventilation of rail car. Step 6. After the minimum 6-hour aeration time, rail cars may be reoccupied when the concentration of Vikane is 1 part per million or less, with all doors and windows closed and ventilation systems turned off, as measured by a detection device with sufficient sensitivity, such as an Interscan, Myron, Safari, or Spectros Explorer gas analyzers. Aeration Procedure 2. If onboard railcar ventilation systems are operable, actively ventilate the railcar for a minimum of 2 hours using the following procedures. Step 1. Remove all tape, seals, and/or tarps. Step 2, open all exterior car doors. Step 3, open all internal doors such as cabinets, closets, appliances, and sleeping berths. Step 4, in sleeper cars, turn all mattresses askew to expose cavities beneath sleeping berths. Step 5, turn on all onboard heating, ventilation, air conditioning, HVAC systems, and exhaust fans. Step 6, in sleeper cars, turn on all operable wall or ceiling mounted fans. Aeration procedure 2. Step 7. Ventilate the rail car with enough portable fans to provide a minimum 4,000 cubic feet per minute capacity per floor in addition to onboard systems. A bi-level rail car would require 8,000 cubic feet per minute capacity or greater, 4,000 cubic feet per minute per floor. Direct fans in such a manner to create cross ventilation of rail car. Step 8. After the minimum 2 hours active ventilation aeration, the rail car may be reoccupied when the concentration of Vikane is 1 parts per million or less, with all doors and windows closed and ventilation systems turned off, or as measured by a detection device with sufficient sensitivity such as Interscan, Myron, Safari, or Spectros Explorer gas analyzers. Do not reoccupy the rail car or move the rail car until aeration is complete. Warning signs must remain posted until aeration is determined to be complete. Latent mortality. Sometimes live insects may be found immediately after a fumigation. Under optimum conditions, the target pest will be dead or dying by the end of the fumigation period. Latent mortality in insects occurs for exposures very near mortality threshold levels. Researchers have observed a delay in mortality of 3 to 5 days following exposure to Vikane. Therefore, judgment of the success of the fumigation should not be made on the presence of live organisms immediately following the fumigation. Non-target organisms. Live organisms which are not specific targets of the fumigation may be found within the fumigated space following aeration. This does not indicate the fumigation failed to control the target pests because lethal dosage requirements may be higher for non-target organisms than for target pests. Also, the non-target organism may have entered the structure during the aeration period. Site-specific considerations, such as chambers, vehicles, ships, passenger rail cars. 10. When fumigating chambers, vehicles, ships, passenger rail cars, containers, or any other structures, all appropriate label instructions apply, such as structure preparation, posting, securing, fumigant introduction, and aeration. Site-specific considerations are discussed below. Chambers. Load chambers and stacks so that adequate air movement can occur around fumigated items to allow even distribution of the gas. Atmospheric pressure chambers, design and construction. A suitable atmospheric fumigation chamber consists of a sufficiently gas-tight room with an appropriate door, an application system, exhaust fan, and a small circulation fan for gas distribution are recommended. Exhaust fans. The size of the exhaust fan will depend upon the size of the fumigation chamber and the aeration time requirements. Generally, a fan capable of changing the air in the chamber in 5 to 10 minutes is recommended. The chamber should exhaust Vikane away from adjoining buildings or work areas. Consult your state agency for emission control requirements. Vacuum chambers. Vacuum chambers require special designs that take into account the vacuum pressure exerted on the materials of construction. For this reason, it is recommended that trained engineers be consulted before constructing a vacuum chamber. Follow all directions given by the manufacturer or design engineer. Specially built steel chambers for vacuum fumigation provide the fastest and most effective fumigation. After the commodity is placed in the chamber, pumps evacuate air. Vikane is introduced and rapidly penetrates all space previously occupied by air. A lethal dosage of Vikane results when the proper concentration is maintained for the required fumigation period. Drawing a vacuum. A vacuum of 25 to 27 inches of mercury is commonly drawn for vacuum fumigations. It is advisable to check to ensure that the vacuum is maintained according to plan. Unplanned vacuum release indicates leakage. Note that some vacuum fumigations are planned to allow release of the vacuum during exposure with the objective of improving penetration of the commodity as air enters the chamber. Introducing fumigant. Because of the special design of vacuum chambers, it is recommended that the manufacturer or design engineer's operation procedure be followed. A small fan can be used to distribute the gas uniformly in the chamber if the vacuum is to be maintained throughout the exposure period. Dosage monitoring. The fumiscope or similar device cannot be used to measure Vikane during a vacuum fumigation unless the vacuum is released. If the vacuum is maintained and thus no gas is leaking from the chamber, the achieved ounce-hour dosage can be calculated by using the simple concentration times time formula. Aeration procedures. At the end of the exposure, release the vacuum. It is recommended to purge the chamber of air fumigant 2 times by pulling a partial vacuum prior to checking the gas concentration for re-entry purposes. For both atmospheric and vacuum chamber fumigations, load chambers so that the adequate air movement can occur to allow distribution of the fumigant. Aeration procedures. Application of chlorpicrin is not required for chamber fumigations if the chamber 1 can be inspected prior to fumigant introduction to confirm that all persons, domestic animals, and pets have been vacated, and 2 is secured to prevent the chamber door from being opened using normal opening or entering processes by anyone other than the certified applicator in charge of the fumigation or persons in his or her on-site direct supervision. Aeration procedures continued. An introduction fan, circulation fan, is recommended when introducing Vikane into chambers to distribute fumigant throughout the chamber. However, if a sufficient open space is not available, or if use of an introduction fan is not practical, an introduction circulation fan is not required. Introduce the fumigant in a manner to avoid a fog out slowly and not apply liquid Vikane to the surfaces of fumigated commodities. Aeration procedures continued. Aeration of Vikane from the chamber head space is generally very rapid, but desorption from fumigated items can occur for a longer period of time. Always check for the concentration of Vikane with a suitable detector before entering the chamber without proper respiratory protection. It is advised to keep the exhaust fans running during the aeration period and also while unloading the chamber. Only the certified applicator can authorize the removal of warning signs when it has been determined that the concentration of Vikane in the chamber head space is 1 parts per million or less. Contact Douglas Products for consultation regarding any specific question regarding construction of fumigation chambers. Tarp stacks. Fumigations may be conducted in temporary chambers created using tarpaulins or other gas-impermeable sheeting as the walls to hold in the fumigant. These are also called stack fumigations. It is recommended to place items on a sufficiently airtight underseal, such as another tarp, polyethylene, concrete, or asphalt, with practical and cover items with impermeable sheeting, for instance, tarp. The edge of the tarp can be sealed either by weighting the edges with soil, sand, snakes, or equivalent, or by rolling and clamping the edges with the underlying tarp, if used, to envelop the fumigated items. See the chapter on fumigation preparation for information on tarps and sealing methods. Monitoring these fumigations is recommended since the HLT may be difficult to estimate using the Fumiguide system. Tarp stack fumigations must be conducted outdoors or in a building that must comply with all requirements for a structural fumigation. Removal of people, pets, and plants, use of warning agent, posting of warning signs, etc. Tarp stack fumigations must be conducted outdoors or in a building that will not be occupied during fumigation and aeration periods. Vehicles, vessels, and containers. Vikane is not registered for the treatment of aircraft or underwater vessels. Passenger rail cars and empty and loaded shipping containers, trucks, automobiles, buses, recreational vehicles, including campers and trailers, surface ships, and other transport vehicles or vessels may be fumigated in essentially the same manner as small structures. Monitoring these fumigations is recommended since the HLT may be difficult to estimate using the Fumiguide system. Automobiles may remain in garages that are being fumigated. However, the applicator must be able to inspect all areas of the vehicle, including the trunk, prior to fumigant introduction. In-transit fumigation, including aeration of any vehicle, is prohibited on public roads or waterways. Do not move a vehicle while under fumigation. Follow all local, state, and federal regulations covering the fumigation of vehicles and vessels. Selection of fumigation location. Place vehicles, containers, and vessels in a location that is appropriate for conducting a fumigation away from other work areas. Small pleasure boats may either be removed from the water and fumigated on land or fumigated in the water. Large vessels such as houseboats and ocean-going vessels such as freighters and cruise ships can be fumigated in the water at dockside. Securing the vehicle, vessel, or container. Secure the vehicle to prevent entry by unauthorized person using normal means during the fumigation. It is also advised that the vehicle be secured by setting the brakes and blocking the wheels so that the vehicle will not move during the fumigation and aeration periods. Surface ships. Follow all local, state, and federal requirements for ship fumigation, including those required by the United States Department of Transportation, Chapter 1, Parts 147A.1 through 147A.43 in the Code of Federal Regulations, Section 46, Shipping and the Label for Vikane. Since the codes listed are for fumigants in general, do not use procedures that are not permissible for Vikane as directed by label instructions and regulations. The certified applicator and ship's captain or owner shall follow the requirements listed on the label for Vikane and local and state requirements. Except for those persons involved in the fumigation, no unauthorized persons may be on board during fumigation. Fumigation of vessels on water. If vessels are sealed by tarping, it is common practice to extend the tarps below the water surface, unless restricted by local or state regulations, taking into consideration the change in water level in tidal water and how this may affect tarps sealed around the lines, mooring the boat to the dock. Water acts as an excellent barrier for the Vikane because of its low water solubility. When using the Fumigide system to estimate HLT for fumigations in water, experience has demonstrated that using the slab rating to describe the water under seal is appropriate. Securing passenger rail cars. Follow either procedure number 1 or procedure number 2 for securing rail cars. Procedure number 1. A thorough walk-through inspection must be performed of each rail car with doors being immediately locked upon leaving each car. Post a guard during fumigation introduction, exposure period, and aeration. Because a guard is posted, application of a warning agent is not required for passenger rail cars. Procedure number 2. A thorough walk-through inspection must be performed of each rail car with doors being immediately locked upon leaving each car. If no guard is posted, then applying a warning agent following instructions per label directions. To secure the passenger rail car against unauthorized entry during the fumigation exposure period, use a locking device or barricade on all exterior doors or doorways. A locking device or barricade must be demonstratively effective in preventing an exterior door or doorway from being opened using normal opening or entering processes by anyone other than the state licensed applicator in charge of the fumigation or persons in his or her on-site direct supervision. Consult state and local regulations for any supplementary instructions and local restrictions on securing against entry. How to measure a building to be fumigated with Vikane gas fumigant. How to measure a building to be fumigated with Vikane gas fumigant, an aid to estimating. There are several very important factors to consider when estimating a fumigation. Probably the most important is accurate measurement. In simple terms, the cubic content of a structure is determined by multiplying the length by the width and then multiplying the result by the height. In actual practice, the calculation is usually more involved, since most structures are irregular and have peaked or gabled roofs. Therefore, the first step in calculating the cubic contents is to determine the area of space to be fumigated. Then multiply the area, square feet, by the average height, feet. The building shown in Figure 1 is 40 feet long and 40 feet wide, with an average height of 14 feet. The length times the width equal the area. 40 feet times 40 feet equals 1,600 square feet. Area times average height equal the cubic content. 1,600 square feet times 14 feet equal 22,400 cubic feet. Fumigations are usually priced in units of 1,000 cubic feet, MCF. Since the cubic content of this structure is 22,400 cubic feet, 22.4 MCF, the selling price of the fumigation will be the price per MCF times 22.4. This is a very basic example. However, a fumigator must be able to calculate the cubic content of buildings much more complicated than this. He also must understand how to determine the average height. The building in Figure 2 is still simple, but a little more complicated than the one in Figure 1. It can be noted that a lean-to has been added to the main structure and that there is also a crawl space or sub-area. The same procedure is used, but the cubic content of each section should be calculated separately. Section 1 is the main section, not including the attic and sub-area. Section 2 is the lean-to, not including the attic and sub-area of that section. Section 3 is the attic of the main structure. Section 4 is the attic area of the lean-to, and Section 5 is the combined sub-areas below the main structure and the lean-to. Example 1. 40 feet length by 30 feet width equals 1,200 square feet. 1,200 square feet times 8 feet height equals 9,600 cubic feet. 2. 30 feet times 10 feet equals 300 square feet. 300 square feet times 6 feet height equals 1,800 cubic feet. 3. 40 feet times 30 feet equals 1,200 square feet. 1,200 times 1/2 of the attic height, which would be 3 feet, equals 3,600 cubic feet. 4. 30 feet times 10 feet equals 300 square feet. 300 times 1/2 the attic, 1 foot, equals 300 cubic feet. 5. 40 feet times 30 feet equals 1,200 square feet plus 30 feet times 10 feet, 300 square feet equals 1,500 square feet. 1,500 times sub-area height of 2 feet equals 3,000 cubic feet. Total number of cubic feet would be 9,600, 1,800, 3,600, 300, 3,000. The total would be 18,300 cubic feet. The average height of a building with a gable roof is usually calculated by multiplying 1/2 the distance from the ground floor ceiling to the peak of the roof by the number of square feet in the attic. Another method is to multiply the maximum height at the peak by the number of square feet and dividing the result by 2. If the building has a simple roof without dormer or extra gables, as in Figure 3, the average height of the total building can be calculated by adding the wall height and 1/2 of the attic height. There are several methods for determining the average height of a building. One is shown in Figure 4. From the midway point between roof peak and eave, measure to the ground. If the terrain is sloping or access to the outside is difficult, it is often useful to measure the roof from inside while making the inspection. Figure 4. The structures illustrated to this point have all had square or rectangular foundations. In practice, many buildings, such as the one shown in Figure 5, have less regular foundation plans that may pose a greater problem. In such cases, it is helpful to remember that the first step in measuring a building should be to obtain the correct area in square feet. The central portion of the foundation plan in Figure 5 has several sections jutting off from it, marked off on the drawing by dotted lines. One of the easiest ways to determine the area of this building is to consider these small areas separately. Example 1. 32 feet by 44 feet equal 1,408. 2. 16 feet times 10 feet equal 160. 3. 12 feet times 10 feet equal 120. 4. 10 feet times 8 feet equal 80. The total square feet is 1,768.
It is usually a simple matter to find the area by this method, regardless of the number or size of the sections. So you can see on here, we can basically take each section, calculate the area, and then add them all together at the end.
To this point, we have covered only the basic method for estimating the cubic content of the structure itself, but there is more to consider before the final price can be determined. Buildings have overhanging eaves, high chimneys, porches, stairs, and other appurtenances that will have to be enclosed with a tarp, and these will increase the cubic content to be fumigated. Figure 6 shows a dwelling with wide overhanging eaves and a porch and stairway that must be covered. The tarp will angle from edge of roof eaves to the base of the foundation, so a safe rule to follow is to include one eave for each wall length or width to be measured. In this instance, the porch presents a further problem. The extra cubic content is calculated for the space beginning at the roof eave and extending out over the outer edge of porch to the ground level. It is not difficult to measure this additional space if a fumigation tarp is visualized enclosing this area. The building shown in Figure 7 has 3 additional spaces to fumigate besides the main structure: the area around the chimney, the offset between the eave of the house and the eave of the garage, and the offset area near the front door where the garage joins the house. Some consideration should also be given to the 2 different roof levels. There will be some space enclosed underneath the tarps where they extend over the garage, the volume depending on how closely the fumigation crew contours the tarps to the building. Figure 8 shows a building with a chimney and overhanging eaves to cover, together with some additional space near the front door that could possibly add 3,000 to 5,000 cubic feet to a structure that in itself might measure as little as 12,000 to 15,000 cubic feet. If this additional space is overlooked, the measurements could be off as much as 25 to 35%. Figure 9 presents still another problem. The dormer windows on the roof will alter the roof height. These dormers reach above the midway point between the eave and the roof peak. Therefore, it would become necessary to figure the average height using the point where they join the roof. In most cases, dormers extend out as much as 3 or 4 feet. This particular building also has 2 different roof heights. Buildings as large as this require great accuracy in measuring. Every possible contingency cannot be covered in written instructions. For example, there will also be buildings with full basements and others having an interior ground level considerably lower than the exterior grade, which increases the average height, thereby increasing the amount of space to be fumigated. Both overestimating and underestimating are economically dangerous. One results in a waste of Vikane gas fumigant, and the other creates the risk of fumigation failure. If the fumigator takes the estimator's measurements and undershoots a job, his readings on the fumiscope will be misleading, and considerable time can be lost trying to determine what is wrong. Since dosages of Vikane gas fumigant are determined using the Fumiguide B by the half-loss system, wrong measurements can yield erroneous half-loss times, resulting in ineffectual sublethal dosage. Although at first glance the differences in half-loss time appear slight when comparing two measurements of only a few thousand cubic feet difference, when you are working with high half-loss times and low dosages, the reduced dosage caused by this difference can result in a failure. The same holds true with other fumigants as well. Much time and money has gone into establishing correct dosages of all pesticides. This information is placed on the label for the benefit of the user, and it is important that the instructions be adhered to strictly. Experience has shown that if all the factors that influence a fumigation are plugged into the instrumentation system as accurately as possible, the fumigation will be successful. Since precision in measurement is a factor that can be controlled, it is very important to make thorough and accurate measurements in estimating a fumigation. Appendix: Measuring a circular building. Measuring a circular building is really only slightly more complicated than measuring a rectangular or square one. First, you will need to determine whether you're dealing with a dome or a cylinder, since the ways of measuring them are different. Figure 10, for instance, contains both a dome and a cylinder. From point A to point B, the building is a cylinder. From point B to point C, the building is a dome. These two parts of the building will have to be measured separately and the results added together. Cylindrical structures. To measure the cylindrical portion of the building, point A to point B, use the following steps. 1. Determine the diameter of the circle formed by the cylinder. In Figure 10, this diameter is 20 feet. 2. Multiply the diameter by itself. For Figure 10, this would be 20 feet times 20 feet equals 400 square feet. 3. Determine the height of the cylinder. For Figure 10, the height is 40 feet. 4. Multiply the height by the figure you got in Step 2 for Figure 10. This would be 40 feet times 400 square feet equal 16,000 cubic feet. 5. Multiply the number you got in Step 4 by 0.785. For Figure 10, this would be 16,000 cubic feet times 0.785 equal 12,560 cubic feet. This is the volume of the cylindrical portion of the building. Domes. Next, you will need to determine the area of the dome, point B to point C. This may be done as shown in the following steps. 1. Determine the diameter of the dome at its base. In Figure 10, since we already determined the diameter of the cylinder, and we can see that the dome has the same diameter, we know that the diameter is 20 feet. 2. Multiply the diameter by itself. For Figure 10, this would be 20 feet times 20 feet equal 400 square feet. 3. Multiply the number you got in Step 2 by the diameter again. For Figure 10, this would be 20 feet times 400 square feet equal 8,000 cubic feet. 4. Multiply the number you get in Step 3 by 3.14. For Figure 10, this would be 8,000 cubic feet times 3.14 equals 25,120 cubic feet. 5. Divide the number you got in Step 4 by 12. For Figure 10, this would be 25,120 cubic feet divided by 12 equals 2,093 cubic feet. The number you got in Step 5 should be the volume of the dome you measured. This simple method should work for all domes of half a sphere or less. Domes of more than half a sphere are unlikely to be encountered. So, to determine the volume of the building represented in Figure 10, add the volume of the cylindrical portion, 12,560 cubic feet, to the volume of the dome, 2,093 cubic feet. For Figure 10, the total volume of the building would be 14,653 cubic feet. Congratulations! You have completed Part 2 Vikane Fumigation Manual on how to measure a structure. Please proceed to the quiz.